Okay, so in this question we are working with the hydrogen atom. So for hydrogen atom we have the atomic number Z is equals to 1. So in this question it says that the hydrogen and an electron in the hydrogen atom is undergoing a transition, and the initial and the final potential energies ratio is given, and we have to find out the minimum value of the NF, which is the final quantum number in which the electron goes to. So let us say that the electron goes from N1 quantum number to N2. Transition happens from N1 to N2, and let us say that the potential energy of the electron at N1 quantum number is V1, and it changes to V2. Now what we have been given is the ratio of these potential energies, which is V1 by V2 is equals to 6.25, and we need to calculate the smallest possible N2. Now we know that the potential energy of an electron in an orbit is directly proportional to, it is a function of basically Z square by N square, where Z is the atomic number and N is the quantum number. So now we can take the ratio. Since we have the ratio, we can also obtain the ratio of N1 to N2, right? So we can say that V1 by V2 is equals to, using this, 1 upon N1 square 1 upon N2 square, right? Which implies 6.25, which is the ratio of V1 by V2, which is the ratio of V1 by V2 is equals to N2 square by N1 square. Simplifying it further, we get N2 by N1 as 2.5, which is 5 by 2. Now N1 can be written as N1 2 times of N2 by 5. Now using this relation we can see that the value of N2 cannot be less than N2 cannot be less than 5, because if it is less than 5, let us say that N2 is equals to 4, then N1 will turn out to be 8 by 5, which is not really possible, because N1 and N2 both are quantum numbers and they have to be whole numbers, basically positive whole numbers, natural numbers. So it cannot be 4, and because using this relation we can conclude that N2 always has to be a multiple of phi n, basically in the form of this, and here n cannot be equal to 0, n only greater than or equal to 1. Now we want the minimum value of N2 basically, so we just substitute the value n is equals to 1, and therefore N2, which is nothing but n final in the question, turns out to be phi. So phi is the answer.